your time, so I need you to take a look at this video and then we will continue. Okay, I hope you like it. It's related to the states of matter of the water, okay, and all those processes of freezing, cooling, heating, fusion, all those states that we just observed. Okay, so take a look at it.
Have you ever wondered why ice turns into puddles of water on a sweltering day? Keep watching and you'll find out. On Earth, materials exist in one of three main states of matter: solid, liquid, or gas. Materials can change between these states. When a state change occurs, a substance's property will also change. Maybe not too surprising. However, if the state change is reversed, the substance will recover the properties it had to begin with. Neat. Matter can transition between the three states when heated or cooled. But why is heat key in all of this? When a material is heated, it absorbs heat energy. This additional energy can cause attractive forces between molecules to break. This leads to rearrangements of the particles because the attractive forces no longer hold them together as tightly. The same happens when a liquid is heated. The attractive forces between the molecules break, leading them to become more widely dispersed and a gas to form. These four words describe changes in state. Do you know which word refers to which change? Pause the video, fill in the gaps, and click play when you're ready. Did you get them right? Do you know the difference between evaporation and boiling? Both are when a substance transforms from a liquid to a gas. Think of a boiling pan of water. All of the water bubbles. This is because all of the particles have enough energy to become gaseous. But water standing in a pan that is not being heated by anything other than the environment can also turn into a gas. This is evaporation. Only the particles at the surface have enough energy to change from a liquid to a gas. Hence, evaporation is a slower process than boiling, even though it achieves the same state change. Both are types of vaporization. The opposite of these vaporization processes is condensation, the transition from a gas to a liquid. Think of a cold can of soda on a hot day, those water droplets on the outsides, or the dew on the grass in the morning, or the steamed up mirror after a hot bath, even the clouds in the sky, or a foggy windscreen in a car. These are all examples of condensation. Water vapor in the air has cooled down to form liquid droplets of water. Now let's think about the transitions between solids and liquids, so melting and freezing. Think of the Arctic Sea ice. In the summer, when air temperatures are warmer, more heat energy is absorbed by the ice. This causes bonds to break between the ice's water molecules and the ice starts to melt. The solid ice becomes liquid water. But in the winter, the air temperatures are colder, and so seawater freezes, and the ice starts to form again. There is less heat energy within the ice, and so more bonds can form, holding it together as solid ice. So far, so good. But did you know that sometimes when solids are heated, they can turn straight into gases? This is called sublimation. This is only demonstrated by particular materials such as solid carbon dioxide, also known as dry ice. When subjected to a certain pressure, it will turn straight into gaseous carbon dioxide. Liquid carbon dioxide does exist, but it only occurs under very high pressures. Similarly, gases can turn straight into solids when cooled. This is called deposition. Let's check out how much you remember about the changes of state. Pause the video and fill in the blanks. Did you remember them all? Our final thing to discover is that when a material changes states, the mass stays the same. The density changes, so the mass per unit volume, but the mass does not change. Our glass of nice cold Coke weighs the same whether the ice is solid or when the ice has melted. So there we have the changes of state. Just remember that the mass stays the same whatever the state.
If you liked the video, give it a
So now I hope that you liked and enjoyed that video. It's really cool. it relates a little bit to what we're watching in the topic. So now let's continue and do a notebook activity, page 121. And it's this information right here is located in your book, page 121. It's called Work It Out, do the activity heat transfer, okay? We're going to do this activity to see what we have learned. The activity is this one, okay? Curious scientists, work it out, heat transfer. Well, these are the indications and this is an image shown. It says, instructions. Look at the picture on the left, this one, and answer. Number 1. Which item in the picture has a higher temperature? Look at this picture, okay? Observe the hand, observe the eyes. Imagine yourself, try to do it yourself. Go to the kitchen, grab some ice cubes, put it on your hand, and you will see it's the same picture of what you observed to your left. You have to answer these following questions in your notebook, okay? You need to remember to put your name, okay? The date, put your name, date, the title. This is the title. The title, and you need to answer these questions, okay? Question number 2 says, which item has lower temperature? According to what we just learned, which one has lower temperature? Remember how was the ice, and they were saying who has more temperature, okay? So now let's continue. The other one says, describe the heat transfer in this case. What has happened to the heat? Who transfer heat to the ice? Is it the hand? How does it happen? Or how? Okay. What will eventually happen to the ice cubes? After holding ice cubes for a long time on your hand, what happens to the ice cubes? What happens to the ice cubes when you're holding the ice cubes on your hand for a while? Okay? What do we call this change in state? What happens when an ice cube, okay, that is solid will change into what? In this method drops into liquid. So what will happen? What is this change in state called? Okay, so I need you to answer those simple 4 questions. Long sentences, please. Remember to check your spelling, your handwriting. Put number 1. You need to write down the questions, okay? Don't forget to write down the questions with pen and answer with pencil. Okay? So this is a notebook activity, really simple, and this is because I want to see if you understand what we just learned, okay? I hope that I'm trying to tell you, or I hope that you understand clearly this information, okay? To see what is the difference from these states, okay? So now for this activity, I will give you some minutes for you can do it. I will give you 10 minutes to do this activity, okay? So I hope you do it and enjoy it. Okay, guys, you're done, and I hope that you did an excellent, fabulous job doing that activity. It was really simple, just trying to answer the questions that shows there. Okay, so now let's work on page 122, exercise number 3. Okay, we're going to focus now on exercise number 2. It is getting pairs, we won't do it. Explain how the change in state occurs in water and then classify them into progress or regressive. So first we're going to explain how the changes occur in the water, okay? And then we're going to classify these ones over here in progressive or regressive, okay? So for this part, you have to go back and read page 120 and 121, that green information, because it talks about line AC is fusion, okay? So in a moment I will help you. So you have to do exercise number 3. I will give you some minutes for you can do it. I will give you 5 minutes to do it, and then together we will check our answers. Like I said, for this information or for this part, you need to go back and read page 120 and 121, the green information, okay? Check where it says fusion, evaporation, condensation, and solidification. Remember, it's where it says line AB, line CD, okay? You need to check those parts, and it says fusion is when ice or this happens, okay? So please, in 5 minutes I see you, okay? So try to do it. Okay, guys, now I hope that you're done, and I hope that you answer everything correctly, that you have all exercise number 2, and I hope that you understand everything. Okay, so now let's check our answers together according to the information that I have. Okay, exercise number 3 says to explain how the changes in state occur in water and then classify them into progressive or regressive. Well, in function, in that part, according to what I have, says that the ice absorb heat, that the ice absorbs heat. The temperature rises, and the kinetic energy is greater and the ice becomes and the ice becomes liquid. Vaporization says that the water boils. Let's put it with another color for you can understand that part. Vaporization is when the water boils, temperature and kinetic energy rises, and liquid becomes vapor, and the liquid becomes vapor. Okay, so now let's see the other part. Condensation is when the temperature and the kinetic energy falls. When the temperature and the falls rapidly. The vapor becomes liquid. Okay, and the last one is solidification. Solidification refers when the liquid releases it's when the liquid releases heat. Kinetic energy decreases. Kinetic energy decreases and the water the water becomes ice. Okay, so solidification: when the liquid releases heat, kinetic energy decreases and the water becomes ice. So now let's observe this part, and according to each change in state, let's put them, classify them in progressive or regressive. Fusion: what is fusion? Well, fusion is progressive. Okay, solidification: what is solidification? It's a regressive state. Sublimation is a progressive state. Vaporization is a progressive stage. Deposition is a regressive state, and condensation is a regressive state. Okay, so this is so far what I have. I hope you have similar or the same thing than I do. Okay, so now let's continue on the next part. That will be exercise number 4. I hope that you have filled in the chart of progressive and regressive and follow everything as I did. Okay,